Greetings. Welcome to your video on polarity. Maybe when you hear the word polarity, you think of the poles on the Earth, North Pole, South Pole. Maybe you think about the poles on a magnet, also North and South. Maybe you think of polar bears. You wouldn't be far off. Polarity in chemical terms is the idea that there can be a separation of charge within a molecule. And that last little bit is really important. It's within a molecule. So, in other words, it's a molecule. It says that a molecule can have a positive side or a negative side. I put the side in parentheses because it's not really going to be a side. It's more like an area. But that's the basic idea, that you can have a molecule, a standalone unit that has a separation of charge, a positive side and a negative side. Let me show what I mean by that. Let's see. Consider water. Of course, water is H2O. If we do a Lewis dot structure for water, we should be good with the fact that it'll look like this. You got oxygen bonded to two hydrogens. Now, polarity is inherently an electronegativity concept. So, electronegativity, again, is the idea that some atoms are better at pulling electrons into themselves than others. You need your periodic table, so pause it for a second and grab your periodic table if you don't have one. If you look up oxygen on the periodic table and look at its electronegativity, you'll see that its electronegativity is 3.5. If you then look at hydrogen's electronegativity is 2.1. So what that means is that oxygen is way better at pulling electrons into it than hydrogen. So what that's going to mean is these electrons, which are shared, the shared electrons that you have between the oxygen and the hydrogen, since oxygen is better at pulling electrons in, there's going to be more electrons around the oxygen than there is around the hydrogens. What that's going to do is it's going to give oxygen what we call an acquired charge, a partial charge. So in reference to this bond right here, this oxygen and this hydrogen, since oxygen has more electrons around it more of the time, that gives it what we call a partial negative charge. Now, let me just try to fix this a little bit. This almost looks like a figure 8, and it's just a symbol that we use to show partial charges. Let me see if I can do it again. It looks something like that. I think you're supposed to go over a little bit. But point is that, again, since oxygen is more electronegative than hydrogen, it's going to be more electrons on the oxygen more of the time than around the hydrogen. That's going to give oxygen a surplus of electrons, making it negative, and it's going to give hydrogen a deficiency of electrons, which makes it positive. And that's the idea around polarity. If we were to consider both bonds at the same time, both this bond here and this bond here, oxygen's more electronegative than hydrogen on both sides. So what that's going to translate into is a water molecule that has a separation of charge. You see that hydrogen here is positive, hydrogen here is partial positive. Oxygen up here is partial negative. So what that means is we could draw a line dividing the positive side here of water from the negative side here from water from the positive side down here. One more thing, and that'll be it. So, if this is true, if when considering a water molecule, you have a positive side and a negative side, this side being positive, partial positive, this side being partial negative. If one water molecule comes close to another water molecule, what you're going to see is the positive side of one water molecule attracting the negative side of another. So when we talk about intermolecular forces, this is a great example of it. You see that you have the positive side of this water molecule being attracted to the negative side of this water molecule. It draws the two of them together. So when you see water in the solid or liquid state, we're seeing significant attraction between the positive side of one water molecule and the negative side of another. We'll work on this in a more general sense in the near future, but I hope that made sense, and good luck.